A chemist reacts 150 grams of Na2O with 170 grams of H2O by this equation. Na2O plus H2O yields 2 NaOH. First things first, let's identify underneath our equation what we have of each thing. So we have 150 grams of Na2O and 170 grams of H2O, or water. We're looking to figure out the limiting reactant, which means I need to know how many grams of product I can create if I use all of my Na2O and if I use all of my H2O. If we start with 150 grams of Na2O, I want to turn it into grams of NaOH. Anytime I do a grams to grams, I need to make sure all of my units cancel out. In my first bracket, I want grams of Na2O to cancel out, so I need to put it on the bottom here. I can turn grams of Na2O into moles of Na2O. If I set up another set of brackets, I want moles of Na2O to cancel. I'll put moles of Na2O on the bottom. I can go from moles of one compound into moles of another compound. I'm trying to get to moles of NaOH. And last but not least, once I'm in moles of NaOH, I want to get to grams of NaOH. Now that I have all my units and they cancel out, we can double check grams of Na2O, grams of Na2O, moles of Na2O, moles of Na2O, moles of NaOH, and moles of NaOH, giving us an answer in grams of NaOH, which is what I'm looking for. Now I can put in some numbers. Anytime I have a grams to moles conversion, I'm talking about molar mass, so the mass of 1 mole. The mass of 1 mole of Na2O I find by using the periodic table, adding up the mass of sodium plus oxygen. The mass of Na2O is 61.98 grams. My next bracket compares moles of one compound to moles of another. Anytime I compare moles of one compound to moles of another, I have to use my coefficients to find a mole ratio. Coefficients are the numbers that come in front of each of my formulas. Now I can plug in my ratio. In front of NaOH, I have a 2. In front of Na2O, there is no coefficient, meaning it's a 1. Last but not least, I have a grams to moles conversion, meaning I'm looking at molar mass, and the molar mass is the mass of 1 mole. 1 mole of NaOH I find by adding up the mass of sodium plus oxygen plus hydrogen. The molar mass of NaOH is 39.99. When I plug this in my calculator, I take 150 divided by 61.98 times 2 times 39.99. The answer that I get is 193.56 grams of NaOH. So if I use all of my Na2O, that entire 150 grams, I can produce 193.56 grams of sodium hydroxide. I also need to know how much sodium hydroxide I can produce if I use all of my water. If I start with 170 grams of H2O. If I put grams of H2O on the bottom so that I can cancel it out, I can turn that into moles of H2O. Once I'm in moles of H2O, I can cancel moles of H2O out by converting it into moles of another compound. We want to get to NaOH. And once I'm in moles of NaOH, I can get to grams of NaOH. Now I fill in my numbers. For every 1 mole of a compound, I'm looking for the molar mass. The molar mass of water, or H2O, is 18 grams. In my second bracket here, where I'm comparing moles to moles, that's when I use mole ratio. In my equation, for every 1 mole of H2O, I produce 2 moles of NaOH. Remember those coefficients, if nothing is listed, it's a number 1. And last but not least, I need the molar mass of NaOH, which I found in the problem above. So for every 1 mole of NaOH, it is a mass of 39.99 grams. To solve, I plug into my calculator 170 divided by 18 times 2 times 39.99. This gives me 755.37 grams of NaOH. Now I've shown my work to be able to determine the limiting reactant. The limiting reactant is the reactant that produces the least amount of product. If I compare both of the answers, 193.56 grams is smaller than 755.37 grams. That means the reactant that produced that is considered my limiting reactant. My limiting reactant is Na2O. That means the product, 755.37 grams of NaOH, the larger product, that's produced by the excess reactant. In our situation, water is our excess reactant. And last but not least, the theoretical yield is controlled by the limiting reactant. The theoretical yield says once you've stoichiometrically, or using your conversion factors here, solved for how much product you can make, the limiting reactant indicates your theoretical yield. So if everything goes perfect and I use all of my 150 grams of Na2O, I can get 193.56 grams of NaOH. So my answer for C is 193.56 grams of NaOH. I have more H2O. I have it in excess, meaning that once I've produced 193.56 grams, I have enough water to continue to produce product up until I get to 755.37. However, after 193.56 grams have been produced, I don't have any more Na2O. It runs out and the reaction stops.